Hello everyone, welcome back. Okay, here is the tutorial of angle modulation with Madam Hafiza. So as you can see here is the block diagram of FM. We have crystal oscillator as our FC and audio source as our FM, and here is the frequency modulator, and here is the output, the modulated output. Okay, let's see the question. For figure 1 shows part of direct modulation, frequency modulation transmitter. So it is given the audio signal equation is 2 cos 2 pi 20,000 T volt, and given the unmodulated carrier power is 5 watt developed across 50 ohm resistive load, and the oscillator frequency is 160 MHz. Given also the FM modulator sensitivity is 30 kHz per volt. So here is the questions. For question 1, we need to calculate the carrier voltage, next modulation index and frequency deviation. Number 3, calculate the voltage and frequency at the carrier frequency and each of the first 3 sets of sidebands. Next, calculate the power at the carrier frequency and at each of the sideband frequency found in part 3. And lastly, determine what percentage of the total signal power is unaccounted by the component described in part 4. So let's start with the solution, the information given. Okay, here the VMT is equal to 2 cos 2 pi 20 kHz T, and we can extract the information. VM is equal to 2 volt and FM is equal to 20 kHz. And unmodulated carrier power given is 5 watt. R equals to 50 ohm. And FC equals to 160 MHz. Meanwhile, for the sensitivity is 30 kHz per volt. And you need to refer to this Bessel table. Alright. So first question, calculate the carrier voltage. Alright. So we know that power carrier is equal to 5 watt. So the equation for PC is equal to VC squared over 2R. Right. So substitute, rearrange the equation. So VC is equal to PC times 2R square root. So substitute the information, 5 times 2 in bracket 50 ohm. Now we get the value of VC is equal to 22.36 volt. Next, modulation index and frequency deviation. So first of all, we need to use this equation. M equals to Kf, which is in hertz per volt, times with volt, M divided by FM. So substitute all the information. Kf equal to 30 kHz per volt times Vm, which is 2 volt, divided by FM, 20 kHz, is equal to 3. Now your modulation index is 3. Next, calculate the frequency deviation using this equation. M equals to delta F over Fm. Rearrange the equation. Delta F equals to M times Fm. So M is 3, Fm is 20 kilohertz. Now your delta F is 60 kilohertz. Next question. So let's continue to question 3. Calculate the voltage and the frequency at the carrier frequency and each of the first 3 sets of sideband. So refer to the Bessel table M equals to 3 until the third of first set of sideband. Actually, for this Bessel table, there are until 6 sidebands. But for this question, the first 3 set. So for this question, we need to calculate the voltage and also the frequency. So for the first step, V naught equals to VC J naught is equals to 22.36 times the J naught element, which is negative 0.26, is equal to negative 5.81 volt. For the next element, V1 is equal to VC J1. Substitute the element 0.34 is equal to 7.6024 volt. For V2, VC J2 equals to 22.36 times 0.49 is equal to 10.96 volt. Lastly, V3, VC J3 is equal to 22.36 times with 0.31 is equal to 6.92 volt. So this is for the first 3 set voltage. So here is the frequency. Okay, let's divide into upper sideband and the lower sideband. So we know that FC is equal to 160 megahertz, and then FM is equal to 20 kilohertz. So now for the first USB 1 is equal to 100 FC plus FM. So 160 megahertz plus 20 kilohertz is 160.02 megahertz. Next, FUSB 2 is equal to FC plus 2 FM is equal to 160.04 megahertz. Last, FUSB 3 is equal to FC plus 3 FM is equal to 1060.06 megahertz. So next is lower sideband. For the first lower sideband, FC is minus with FM, and The answer is 159.98 megahertz. So FLSB second, FC minus 2 FM is equal to 159.96 megahertz. Last lower sideband is equal to FC minus 3 FM is equal to 159.94 megahertz. Next, so calculate the power at the carrier frequency and at each of the sideband frequency found in tree, meaning that we need to calculate the power for the carrier and the first 3 sets. So P naught is equal to V naught squared over 2R. So 5.81 squared over 2 times 50 equals to 0.338 watt. For the first sideband, P1 is V1 squared over 2R. So substitute all the information as we calculated before. Right, we got 0.578 watt. For P2, V2 squared over 2R is equal to 10.96 squared over 2 times 50 is equal to 1.201 watt. P3, lastly, V3 squared over 2R is equal to 6.93 squared over 2 times 50 is equal to 0.48 watt. Alright. Okay, for last question, determine what percentage of the total signal power is unaccounted for by the component described in part 4. So we know that the power total is equal to P naught plus 2 times P1 plus P2 plus P3. So substitute all the information that we calculate before. PT equals to P naught is 0.338 plus 2 times 0.578 times 1.201 plus 0.48 watt and is equal to 4.856 watt. So to calculate the percentage of unaccounted component, so we know that Px is equals to Pc minus Pt. Pc is 5 watt minus with 4.8656 watt. Now Px equals to 0.144 watt, which is unaccounted value. So now calculate the percentage of Px. 0.144 watt divided by 5 times with 100, and the answer is 2.88%. Okay, so that's all for. Okay, end of our tutorial. See you then. Bye. Thank you.